perfect square root is equal to 4 plus x, which it's not. Okay, we discussed that, I think, was this the same problem I saw earlier? Same problem. And then we said, no, it's not equal to 4 plus x, but I was just interested in the, what, domain? And the domain in this case, what can I replace the x by? And we decided, Professor, you can replace the x by any real number, or this, and that is your domain. You're finished. Now, the reason I thought about this after the break was, we've been doing this also. If it's underneath a square root, of course, that's true. That's the way you deal with a square root. If you take a look at it like this will not factor. I wish it would. If it did factor, you could go into sign analysis and start testing and all that. No, this says 16 plus x squared, a little common sense. Is 16 positive? Of course it is. Is x squared next to it plus x squared is x squared, implying if you square it also positive? So aren't you adding 16, some positive? Is all that left-hand side going to be positive no matter what? So will it satisfy this inequality? Will all the answers be greater than or equal to 0? You will never get a negative number on the left-hand side. So we talked about that. With that said though, part 2. Given, Aiden, do me a favor.
Yeah.
On the handout for the review for the test, tell me what the function was where I asked you to find f of 2, f of a negative 3, some of those. What was the function given to me in that part?
F of x is equal to 8 minus half times x plus 3 squared.
Beautiful. Guys, on this exam, don't miss one of these. You can't miss one of these. I'll give the function to you. Then we'll ask you to find the function value for me, and I'll give you a specific number to work with. Aiden, what was the first one to find what?
0.
Nice. F of 0. I said, Professor, what does that mean? I would actually do it, but it means this. You're going to replace x with 0. That's all it means to do. Now, the only place you can mess up now is arithmetic. And we all mess up on arithmetic, so to speak.
Instead of 2, it's a 3.
3 where?
X plus 2.
X plus 3?
Yeah, it's x plus 2.
Okay, X plus 3. And guys, all of us have, can't make mistakes in the arithmetic. Be careful. This is 8 subtract 1/2. Looks like it might be a 9. 3 squared? If I'm careful, I tell you, arithmetic can get us 8 subtract, on the end is 9/2. 1/2 times 9.
3.
And if I put those together with a common denominator of 2, I don't think it's going to be a nice number here, but if I put these two together, guys, please tell me, can I write this with a common denominator of 2? 16 over 2, is that 8? I just renamed 8. 16 over 2. And what's 16 subtract 9? 7. Don't scare me.
No, sorry.
We're going to quit taking breaks. 7 over 2. And you may crunch your numbers out a little differently, but 7 over 2, if I have no mistake there. You're done. Full credit. Now, based on what we did before the break, I always like to make connections here. There's no need to teach math, not make connections here. What you've actually found was, he gave me x3 0. You actually found the y is this. It's an ordered pair. So I'll have some of these on the exam where I'll give the x to you and ask you to find the y. So I'll give. Aiden, tell me what number 2 was asking.
F equals negative 3.
Negative 3? Here we go. Go back to my function. Be careful. Replace x by, that's all it says to do, negative 3. And if I replace x by, right here's x, by negative 3, looks like that. Oh, this one's going to be cubed. 8 subtract 1/2. Guys, I think this is 0. Negative 3 plus 3 is 0. Square is still 0. And 1/2 times 0 is still 0. I'm going to end up with merely what? 8. Done. And just leave it like that. I'm happy. Aiden, what was number 3 then? I'll get out of your way here.
Negative 3 over 2.
-3/2. Guys, if I'm patient, because I will have some fractions on the test, 8 subtract 1/2, and I'm replacing by -3/2 plus 3. I'm going to step back and make sure I have all that copied down correctly. Replacing this x right here with a -3/2, beautiful. Okay guys, crunch time, be careful. 8 subtract 1/2. Now inside here, please tell me, the arithmetic could be thought of as doing that. -3/2 plus 6/2. I think 6/2 is another name for 3. Does that make it easier for you? Add them up, that's a -3 on top. I apologize for 3. All of my common denominator, 2. Does it make it easier for you? Put those fractions together? So it looks like if I have no mistake, this is 3/2 inside here. Of course, it's being squared. Yes, no?
Yeah.
Okay, not quite finished. Now it says 8 subtract 1/2. Guys, if I square that, that's 9/4. It's just a little testy here because of the fractions. More 8 subtract this on the end. Best I can do here is write that as 9/8. Now put those two together with a common denominator of 8. Guys, I'm write that 8 out front as 64/8. And I'm subtracting from it 9/8. Just put things with the common denominator. 64 subtract 9, I think it's 55. I think. So if I do not have a mistake, it's 55/8. Is it, guys? I did it quickly. That's what we're doing. Only way you mess up on this is arithmetic. 8, what's the next one?
A minus 1.
A minus 1?
A.
A
Yeah,
minus 1.
Yes.
Gotcha. Same thing. Go to my function that he gave me. Replace. And I'm replacing this x, where it was up back here, right here it is. He says put in an A subtract 1, Professor. Let me do this, since these things are getting a little tricky here. Let me use the green here. I put in A subtract 1 for the x. That's got plus 3 inside there. This will be interesting. And then you're going to square it. Let's see what might happen if I do that. 8 subtract 1/2. Guys, inside there I think is A plus 2. See if I'm correct. -1 plus 3, is that 2? And if I say clean it up further, 8 subtract 1/2. Now here goes. This is some basic stuff to do. So what is A plus 2 quantity squared? Going to give you
A squared plus 2A plus 4.
A squared plus 2 again?
So it's 2A.
Hold on. 4A plus 4. Interesting. Just doing some little basics here to make this look good. So this becomes 8 subtract, oh, here goes, guys, you're gonna multiply all those by 1/2, strictly property. I've gotta be careful myself here. We end up with minus 1/2 A squared. When I reach the 4A, I'm minus 2A. When I finally reach the 4 on the end, minus 2. See if you guys agree. And I'm looking closely, I do see some numbers can be put together. The 8, the -2 to make it look better can be combined to a 6. If you want to put a 6 there, but you still have this. Minus 1/2 A squared minus 2A. And that looks strange, but that's the answer. That's F of A minus 1. Cannot go wrong on these guys. I guarantee you every student in class is going to get some partial credit on every one of these. The only way you really go wrong is at the end when you start the arithmetic or the algebra. Yes?
At the end, the final answer doesn't matter if we order.
What's it now?
Does the order matter? Like,
No, it does not.
No?
No, you just leave it like that, I'm happy. You get to that point, I'm happy. Guys, anything else? Aiden, what's next?
That's it,
Oh, that's it?
for that section.
I didn't ask anything else?
No, not in that section.
Whoa, okay, hang on. I'm gonna do this right now, it's number 4 and 5. Here goes. Add one more, guys. I know what the test looks like. Oh, Ramsey, good. Same function. One more problem to do here. Same process, it's gonna be equal to 8. Subtract got 1/2. Now, inside there, and I'm gonna be careful. Here's my function, I'm replacing x, right there, with this. That's the x in the function he gave me, right here, replace. Still got +3 on the end. And all that's being squared. So I lucked out here. 3's cancel. And we end up with 8, subtract 1/2. Guys, I still have this inside at this point, being squared. Now, can I say anything about radical x squared?
Drops.
It just drops the square root and gives me what, just x? Look at this cube, drop it. We're done. That's the answer. Finish. Okay, if you didn't see that on the handout, I'll probably bring it in. Okay, I think we pretty much covered everything on the handout. Aiden, am I correct now? We did the domain, we did the other part just now. I think we're pretty much there, aren't we? Okay. Now, remind me, since I do want some good scores, please remind me, right before we leave, to do one more completion of the square. Because you do have a completion of the square on the test Wednesday. So of all problems, I think we need to look at one more completion of the square before I leave tonight. And of course, I'll see you on Wednesday at 4 o'clock also. Guys, that's looking good there. Part 2, what I want to do though now is this. For leading into something here, chapter 1. We'll give you a function. It's a really simple function. 4x plus 5. Simple. And I'm going to actually find. It's going to look a little strange. I'm going into the calculus now. It's going to make some sense of what we've been doing here. Let's actually find something that looks like this. F of x plus h. They can use any variable they wish. Some will use an h. Most textbooks use an h for this topic coming up later on. First, let's like to know what f of x plus h is. And I thought I would bring that in following this. Isn't it the same thing? Just go back to the function and replace. Just do the same thing. So to find it, you say, Professor says. We'll go back to my function and put in place of x. We put right here. Right there. Plus 5. Is that what that means to do? I know it looks strange, but it's going to be something we're going to be using later on. F of x plus h, go back, replace the x by x plus h, clean it up. If I clean this up, guys, we end up with 4x plus 4h plus 5, and you got the answer. Wait till you see what this leads to. Mr. Park knows. We've moved into calculus. That's the first part. Now, number 2, I'd like to find this for a reason. Find f of x plus h, subtract f of x, and divide all of it by h. You say, Professor, what on earth are you going nuts here on a Monday? Jeez, Professor, I've never seen that expression in my life. After you leave me, you're going to math 7, you're going to see it. And we just well get accustomed to it. That's going to be given a name later on. I'll tell you what the name is and show you more about this. But right now, I just want to find that. You say, wait, Professor, you've already found this, but it's right here in the first part. So what they ask us to evaluate this. The first part is merely 4x plus 4h plus 5. We can mark this out, guys. That's that. We did that in the first part. Is that true? Now it says don't stop there, though. And what I want you to do, it says subtract from that, look at this, f of x. Just want to tell me what is my replacement for f of x?
4x plus 5.
They gave it to me. That's the original function. 4x plus 5. I'll put that in red. As if that's not enough, now divide all this by h. That's what it says to do. Now, what does it mean right now? I doubt if many students, if any, right now, because I don't know how many of my students have had a little calculus somewhere. You may not be able to tell me right now what this means, but wait till you see what it means. I am going to clean this up, though. Guys, if I clean this up, please tell me, will I end up with, in the green, I'll use the blue marker, this, down on the end of the red, distributive property, distributes the negative. We'll end up with that, and all that's over that. Just clean it up. Clean it up further, the 4x terms will cancel. 5's cancel. I'm going to end up with 4h over what? H. Now what happens? H is canceled. Are you kidding? After all that work, the answer's 4. The answer's 4. Professor, what does that mean? I can do it for you, Professor. I can calculate like you did. I'll get an answer of 4 and turn it in, and you'll give me a perfect score for saying that. But if I ask you now on the next part of the test, tell me what it means. I'm going to throw it out there and see if anyone knows what I calculated for you. I'm going to give a name to it here shortly. Does anyone think they know what that 4 represents? And this is taking me into calculus. Let's see, hang on up. Yes?
The slope of the line.
Here we go.
The slope of the line.
Mr. Parker, first time I've heard that in a long time of class. He told me, Professor, you got a final answer of 4 when you crunch this thing out. I see it staring right here. Was there a 4 also back here? And if I take a close look at my function that I gave you, f of x is equal to what, 4x plus 5, was it? He says in his mind, beautiful. He says, Professor, this is in the form of, from middle school, mx plus b. A slope and a y-intercept. You guys remember slope? That's simple there. And by the way, right now with what I have on the board, did all this work, look at all this work I did. It came out to be this. Did that match up with this? So what do you think all this is representing? He told me. He says, Professor, this has something to do with slope. That 4 represents slope. Guys, so in other words, if on an extra credit, maybe, if I did this, I give you this. Moving into calculus. I gave you this. I ask you to find this. Find the same thing I did here on this one. I might, some of my clever students may say, Professor, if I trust what you just said, or my students said, I may not have to crunch anything out. I think I'll see the answer right now. The answer to this, without crunching it out, has got to be negative 2/3. What's a negative? Yeah, it's negative 2/3. That's mx plus b. Slope, intercept. Love calculus. It's negative 2/3. Quickly, a student place on their quiz, or an extra credit on the test, that's just negative 2/3. I'd probably put a little smiley face there and say, I'm happy with that, but now show me. Now crunch it out to confirm. It is going to be a negative 2/3, but now confirm it. That means yes, now go back and crunch this out. Okay, guys, here goes. You gotta be careful. F of x plus h, let's get that first part done. Here we go. That right there, get that done like I did this one. It says go back to my function and please replace, let me do it in a different color, x up there with x plus h. And that's supposed to be a subtract 6 on the end. Drop this off. Is that what f of x plus h means to do? Go back to the function, replace x with an x plus h. Okay, so that is taken care of. Don't stop there, subtract from that, now f of x. You say, well, what's f of x? Well, it's the original function. That's negative 2/3 x, subtract 6. Guys, don't think this is too heavy. It's going to get much better. All over h. Do we now have this set up correctly? Now to clean it up, we hope when we clean it up you get negative 2/3. We hope you get a negative 2/3. Okay, here goes. Distributive property right here, guys. Distributive property. Negative 2/3 x minus 2/3 h. Still got to subtract 6. Down here on the red, negative, being distributed on the red, changes that into a positive 2/3 x down there, and a positive 6. Distribute the negative on the end. Ah, how cute. These cancel. These cancel. Keep in mind all this is still over h. So at this point I have negative 2/3 h over h. And I know, you know, those h's will cancel, and look at that. There's negative 2/3 confirmed. It's slope. It's nothing but slope. Right? Okay. We'll slow down here just a few minutes here. Next one. It's a given. Get you right into it, and we'll talk about it. Bear with me. There's my function. I want to try the same thing. F of x plus h, subtract f of x over h. That's all. Same expression for all these functions. Anyone tell me? Last time a student said, Professor, the answer's got to be a negative 2/3. I crunched it out. It is. Anyone tell me what the answer on this one should be without crunching?
X.
Nope.
1 to 1.
Nope. That's why I love teaching. Love teaching. Love teaching. I always said 1 also. It's not 2x. Oh, I got you on this one. Oh, I got you on this one. I get it. Hang on first. Right here, quickly, the student said negative 2/3. We crunched it out, negative 2/3. The one I did over here, got a 4. The student says 4. Crunched it out, got a 4. I'm saying, can you look at this one right now and tell me, if you can, you may be exempt from the test on Wednesday. Oh.
Excluded.
Not excluded, not exempt. no, worse, not extend. But I want to find that same f of x plus h, subtract f of x over h for this function. And I know what you guys are looking at. I know you're saying, Professor, my goodness, it's the number in front here. It's the number in front here. Not in this case. What did I do to throw it off? I put a square on the x. It's not linear. It's not linear. I don't know what the slope is. Oh, hold on. Yeah, I got you on this one. Now you're hoping maybe for an extra credit on the test on Wednesday that I just give you maybe, Professor, please give me one that looks like that. Professor, even, I would not be upset, Professor, if it looked like this. It looked like that. Now what do you think if I took the time, which I'm not going to, but if I took the time to find f of x plus h, subtract f of x, it's a strange expression we're doing tonight, divide by h, what do you think the answer has to be on that one? And tell me, are you guaranteed just by looking at, can you tell me what the answer would have to be just by mere observation on this one, as you did this one, as you did this one? Does you want to see what the answer has to be if I should crunch it out? Oh, I got you scared. I got you scared. You say, oh, Professor, you said I was wrong on the last one. I'm not going to say anything this time, Professor. Oh, I got you scared. Does anyone have a thought on if it looked like this? Do I know right now what the answer must come out to be if I crunch it out? And I cannot do it here. Does anyone think they know the answer on this one? I see a hand going up. Aye. Aye. It's got to be in that form. And it's just pi. Now, I'm not going to crunch it out tonight that particular time, but if I should crunch it out, I guarantee you bring a pi at the end. Mr. Park. I don't know whether Mr. Park knows it or not. I'm asking them now to find this for x squared plus 4. And we're saying right now it's not in the right form to say the answer is that. The answer is pi, the answer is 4. It's not in that x plus b form because I threw it in x squared. And that's what throws things off. Where do you see what the answer looks like? Crazy. I have not heard one student yet give me what that crazy answer is. Mr. Park, any suggestions? We're trying to find this for that.
We do step by step. We replace x by x plus h.
Okay, Professor, just go ahead and crunch it out. Let's see what it does look like. Here we go. Go crunch it out. Like I crunch the others out. Okay, f of x plus h. Here goes. He says replace x by x plus h. No problem. Squared. Plus 4. We block that off. That's the first. I'll block that out. That's the first part. It says subtract from that. Don't stop there. F of x. F of x is the original function. Done. All over h. That's the way it looks. Ooh, welcome to pre-calculus and calculus coming up. Oh, guys, did I put everything in correctly? Is that the way it looks? Now I've got to simplify it. Here goes. I'm going to expand this out. My goodness, someone's going to help me. The green part, x plus h quantity squared. X plus h times x plus h. I see a hand going up in the back. Tell me what it is.
You want the simplified version or the full?
Yeah, right here.
X squared plus xh plus xh plus h squared plus 4.
Okay, and I heard xh and xh. Let's
So
put
2xh.
2xh. Let's put them together. And then you gave me what, h squared?
H squared plus
perfect for that. That's x plus h times x plus h. Now I do see, we still have a plus 4 here. Now I'm down here on the end. The end's easy. Distribute the negative sign, negative x squared minus 4. All over h. That's the way it looks. I mean, this one looks strange. So let's do the best we can. X squareds will cancel. 4s will cancel. At this point, I'm left with the green, put down here, in the numerator, over h denominator. That's what I'm left with. Not nice, but that's what it is. Does anyone see anything else that could be done?
Take out eight.
Take out h, oh, I love it. Now we'll take out an h on top first. Take out an h, both those terms contain an h. Look, taking a common factor. And of course, I still have the h down here. Aiden, you said that perfectly.
Wasn't the 2x h positive?
Now, about I took the h out. Now can I do something else? Will the h's cancel?
It's positive.
It's positive.
Was it positive or where?
Yeah, positive
Yeah.
x h.
They get, oh, positive 2xh. Got wrong here. Then he tells me to take out an h out, which I did. Now I can even do this. Those h's will cancel. I'm left with now if there's nothing wrong with this, 2x plus h. I don't have anything wrong with it. Now I've got close to 40 students. I did not hear one student say, Professor, this right here is 2x plus h. I didn't hear one student say that. Here, Professor, the answer is negative 2/3. Quite a few students said it was. And it was. Here, the answer was 4. And it was. That one, 2x plus h. Now, let me give a name to this. When they ask you to find this, they call all of this right here, this expression, all of it, they call it a difference. And if I see a difference, quotient. And I see a quotient, it's being divided. So I got a difference going on, I got a quotient going on. So guys, they call this entire expression a difference quotient. F of x plus h, subtract f of x all over h. Wow. Kyle, if I gave you, I'll close this thing down. If I gave you this, just in closing, Kyle, and I ask you to find this thing called a difference quotient, what might you tell me the answer must be, Professor? What? Negative root 2 over 2. If it's the form. Kyle, if I did this to it, I'd ask you to find the same thing. Can you now tell me what the answer looks like? No. What did I do? I messed it up. I placed a 4 there. It's x to the 4th. It's supposed to be just a single x. It's when you tell me ahead of time what the answer should be for this difference quotient. If it's a square, a cube, a 4, whatever it is, you can't do it. You can't tell me. You gotta crunch it out, but you can't tell me what the answer is for me before then. I thought you were checking on the difference quotient. Okay. Now, so guys, I'm closing down. You guys like to see a copy of the test? I'd like to see a preview and just make sure Ramsey's okay and I feel good about it. That'd be nice.
Yes.
I do remember a little short story when I was teaching at the university. Oh my goodness, I was teaching a calc class. I think I had 150 students in an auditorium. 150. And to do a lecture with 150 students and TVs around so that people in the back could see me, madness. Complete madness. I think I had 5 TAs, teaching assistants, to help me. So we got done. And all of a sudden, getting all this stuff organized for my students, I told my TAs to start passing out the tests. We were having a test. And of course, me, trying to keep myself organized in my mind with 150 students, which is hard. My TAs, I gave my TAs the test, and I said, pass them out. What did I do? Oh, the review for the test. I said, pass them out. Guess what I did? I passed out the test on review day. They didn't say a word. That auditorium was packed, and I didn't hear a word. But I could sort of hear something go, she smiled. That's my TAs. In fact, I think it was my TAs. Now thinking back, I think it's my TA's fault. They brought the test in rather than a review for the test. So they passed out the test for the review. Now, did I finally catch it? Oh yeah, I finally caught it. I finally caught it, so I let them go ahead and use it, and that's going to act as your review, which is what's going to be the test. I had to create a test. So you guys want to see a preview of the test? You know you're not going to see a preview. Now, and slow down these last few minutes. One concern I have, really big concern. You have that review right there handy? Guys, if you know all this, the answers are on the back. Just one page. And Mr. Park is going to send out solutions. He's going to actually work these out for you and send the solutions out to you. You have the answers on the back here. If you know this, you're going to do well on the first test. Please get started off with a good score on the first test. Because the material's going to get a little tougher as we move along. So do it now. Get a good score. I want to do one completion square. Then I got to have you guys do something for me. Should I just create one right quickly, make it as hard as I can, and do it?
Yeah.
Here we go. It'll be on the handout. Guys, you will have a completion of the square on there, on the test. Here goes. I can solve. Guys, I'm standing here, I don't know how crazy this will get. But it's solving this. And I say do it by completion of the square. In other words, you've got to show all the steps in completion of the square. Can anyone help me out? You're closing out tonight. What would you do first? Divide everything by 4. Because it's step 1. This is division by 4. Which will give me x squared. Be very careful. Subtract 3 over 4x. Subtract 6 over 4. 0.
Can we simplify?
You can, you call that 3 halves.
Yeah.
Lisa, you call that 3 halves. Which might be wise to do to make it a little bit easier for me. Okay? But right now, step 1. I give you partial credit for this. Step 2, and that's to make that leading coefficient of 1, which we've done. What's the next step?
Add 6/4.
Okay, move that 6/4 over. I like that. Get it out of the way. By the way, as I start moving it over, and just leave the x's on one side to themselves, I think that's telling me I'm also ready for, just do it right now, ready for that addition or completion that I need. So the 6/4 has to be moved over. You're going to have to add something to each side to now make the left-hand side a nice, perfect square. Hang on just one second. Now, Lisa was telling me it might be wise going and call that 3/2. I'm gonna leave it 6/4 for right now. It may be easier about 3/2.
Next, you have to,
Was that the same question?
no, I was gonna explain the
Okay.
next step.
Guys, this is where you may mess up. Please be careful. What is required to add, you gotta add on both sides, to make this eventually come out to be, I'm gonna write step 3 here, in blue. To make this left-hand side a nice, perfect square, that's why they call it completion of the square. Anyone remember the little process to find the right number? If you don't put that right number on that blank, it's messed up. Katie?
Would it be, so, before you square it, it's -3/8.
I can take 1/2 of it. And she tells me, Professor, that's -3/8. Hang on. So you take 1/2 of this coefficient of the x, is that true? And then do what to it?
Square it,
Thank you.
you get 9/64.
Look at that. Get 9/64. If you place the wrong number, guys, I can't do much for you. So 9/64, she is perfect. 9/64 here. 9/64 here, both sides. Now, if she has the right number, and I'll tell you she does, can anyone tell me what that entire left-hand side of those 3 terms looks like as a factored perfect square?
X minus 3/8.
I'm hearing it. X minus how much?
3/8.
Oh, look at that. Exactly. It's gotta be. That's a nice perfect square. The other side is across the street. Combine fractions with a common denominator, guys, we use a 64.
So we multiply by 16.
There you go. Oh, my students are on it. Multiply this by 16. 16. I'm gonna end up with 96 plus 9, I think. Is it 96 plus 9?
Yeah.
What is that, 105?
Yeah.
I'll put it real quickly. Strange number, but I just created this just standing here, so it's 105/64. Jeez. Okay. Do we all agree with that? Okay. Strange number there, in my case. They're asking me to solve for x. I'm gonna get x eventually by itself. Now it's time to do what?
Square both sides.
No, not square root. No, take a square root. And the left-hand side's nice, merely this. Now, this is where I ask you to do this, plus minus, because we have to get how many answers? 2. This is a quadratic. So that plus minus, it's gotta be in there to ensure you get 2 answers. Now, I'm left with now square root 105, which is not a perfect square root. I'm standing here as your professor. I'm trying to break it down myself. Will it even break down? Can I simplify it? It's not perfect. 105, Mr. Park, help me out. 105? Do you know how to simplify square root 105, or must we leave it as 105?
Absolutely.
I know 5 times 21. Is 5 times 21 105?
No.
But neither one of those is perfect. 5's not a perfect square root, 21's not a perfect square root. Is that true? So that wouldn't help me. Guys, I think I want to leave it square root 105.
Over 8.
No, there you go. Bottom part, yeah, I'm with that. So Lisa says, that's you might leave that 105 the way it is, you can't do anything to it. But, square root 64 is 8. Now, see, one more step, you're finished. Move the 3/8 over, they ask me to solve for x, so get x by itself, you're going to end up with 3/8, plus minus this crazy number here, over 8. I would like it expressed as 3 plus minus square root 105 all over 8. And there's your answer. by completion of the square. You got one of those on the test. Now you know by now, I doubt seriously, with all the work we've done here, I doubt seriously if I would give you like, this was over 64, like 81 over 64. 81 over 64 would be too nice. That would be what, 9 over 8? No, I want something like 105. But I'm trying to come up with something else that would break down, not perfect, but would break down like 28. That's 28, it's not 25. Does anyone know what 28 looks like? Square root 28 looks like simplified? Oh, hang on, your thing's right. 4 times 7. Yeah, 2 root 7. Isn't it 4 times 7? 28. It becomes what, 2